6.6 is rational exponents. And again, when they say rational, they're talking about fractions. Rational means fractions, so fractional exponents. Write each expression in exponential form. Exponential form, they want exponents, they want fractional exponents. So this 5 right here is the root index. That's going to be the denominator of your fractional exponent. 10 to the 4/5 power. That is it. So the number outside here is going to be the numerator, but that root index 5 is the denominator. Get that written down. Bump that up to 2. Number 3, it's really the same thing. This is your root index, so that's the denominator. You're going to have 3m. Notice how all of that is inside the radical symbol. So we're going to put that in parentheses. And then it's going to be to the 7/4 power. So not a big deal, not a lot going on there. That's what we would have. Now simplify. I think it's kind of hard to do rational exponents. I think it's easier if we change it back to radical form. That's what we spent a couple of days on. So let's do that. And so essentially my first move is going backwards. I know this denominator 2 is the root index, so I could write it as a square root. All right, a square root has a root index of 2. We don't really need that 2, but that's what it is. 49n to the 4th. And so the numerator is 1. So what did they do up here? See how they put like an exponent or a parentheses and an exponent? I suppose you could do parentheses with an exponent 1, but that's not going to do anything. Anything to the first power is just to the first power. It's not going to do anything. So that the red to the first power isn't really even necessary. We need to take the square root of 49, and we know the square root of 49 is 7. And we also need to take the square root of n to the 4th. And so remember, this is where you'd say this root index 2 goes into this 4 twice evenly with nothing left over. Simplified. Number 7, write each expression in radical form. So really, this is like step 1 of problem number 5. I want a radical. So there's going to be, this is not called a square root sign. It's called a radical. And it's a square root only when that root index is 2. But in this case, the root index is that denominator, 5. You have to put that 5. If you don't put that 5, it's wrong because you changed it from a root 5 into a root 2. All right, so we're going to have a 3k inside there. And I think the best thing to do is just take all this to the 6th power. Radical form. Don't have to simplify, don't have to do anything else. So then the next one, when I have a denominator 2, that's a square root. That's a square root. We have square root of n, and there's really 2 ways to do it. If we're consistent with the last problem, we'd say to the 5th power. But you could also just say square root of n to the 5th, like that. That's the same thing. Both of those say the same thing. All right. Now, the reason I didn't do that on problem number 7 is if you said the 5th root of 3k to the 6th, does anybody know why that's not right? What do you think? Perfect. The 6 doesn't apply to the 3 there, and it needs to. So this is not right. Okay, that's not the same thing. So if there's only one letter, like the N, you can do that. But if there were 2, I suppose what you could do is like distribute and apply the 6 to the 3 also. Then that would be okay. But I don't know that that's easier than what we did in red. Write each expression in exponential form. Okay, exponential, exponent. We want the exponent. We don't want the radical. And so it seems like we've already done this, but again, here's the root index, so that's going to be the denominator, right? That's your denominator, n to the 7/5 power. Done. Exponential. Next one, 2k. Since there's more than one, I'll use parentheses to make sure it applies to both the 2 and the k. Denominator 3, because that's the root index. Numerator 2. 2k to the 2/3. I think the simplify questions, to me, the simplify questions are the most interesting ones. Simplify, because we've got to convert it, or we want to convert it. I think we want to convert it, and then we want to break it down. So this is a 1/4 root of 81k to the 12th. And again, the numerator of 1, you could put that parentheses in a 1, but parentheses 1 doesn't do anything. Everything's to the first power. With that numerator, I don't need to say to the first power, so I just leave that off. If it's anything else other than 1, though, we need to do extra stuff. All right, so we're doing the 4th root of 81. It's 3, very good. Okay, that's right. If you know that, then you know that. Same thing as when we do square roots. If you know the square root of 64 is 8, then you just do that. Here, if you know the 4th root of 81 is 3, then you just write it down, okay? Some of us don't know that, though. Remember what we do if we don't know what that root is. If we don't know the root, okay, by the way, the reason the 4th root of 81 is 3 is because 3 times 3 times 3 times 3 is 81. All right, and you've seen it several times, and so some of you have that memorized, and that's great. But if you didn't know that, you'd say, okay, let's see how this breaks down. 81 is divisible by 3, that's 27, and 27 is divisible by 3, that's 9. 9 divided by 3 is 3. I see 3 to the 4th. 81 equals 3 to the 4th. So if we're going to do the 4th root of 3 to the 4th, 4 goes into 4 one time. There's your 3. But we also have the 4th root of k to the 12th. 4 goes into 12 3 times. So we get 3k to the 3rd. 3k to the 3rd. Right there. Number 17, 36n to the 6th to the 3/2 power. Remember, rational exponents are fractional exponents. That's what we're talking about here. So let's look at our root index is 2. So that means it's a square root of 36n to the 6th. And then we would take that to the 3rd power. That's your numerator. So we've got a square root. Remember, we don't need that root index 2, but you can put it in there if you want. We don't need that root index 2. It's a square root, but you can put it in there if you want. And so, you know, there's a couple of different ways you can do this, but I would go square root of 36 is 6. Square root of n to the 6th, n to the 3rd, right, because 2 goes into 6 3 times evenly. Then we're going to have parentheses 3. And so we've got 6n to the 3rd to the 3rd. All right, 6n to the 3rd to the 3rd. So I might need a calculator for 6 to the 3rd power, but that's what you're going to have. 6 to the 3rd is 216. Very good. Sometimes you see numbers enough that you just remember them. They come up, but that's good. 6 times 6 times 6 is 216. And then you have n to the 3rd to the 3rd. Remember, if you've got number parentheses number, it's going to be multiplication. 3 times 3 is 9. That's 216 n to the 9th. Or if you want to look at it this way, n to the 3rd means this. That's n to the 3rd to the 3rd. Well, n to the 3rd is n times n times n. So if you look at it that way, you can count up and see there are 9 n's multiplied together, n to the 9th power. But the shortcut there is its multiplication. All right, last one. Don't have a whole lot of room, so I'm going to have to use my space. I don't know, be creative about that. I see a denominator 3, so I know it's a 3rd root of 8n to the 6th. But then the numerator 2 means that the whole thing is going to be squared. So third root of 8. Anybody know third root of 8? It's 2. Very good, because 2 times 2 times 2 is 8. That's right. Okay. The third root of 8 is 2. Again, if you didn't know that, you could break it up like this and see that 8 equals 2 to the third. So you're doing the third root of 2 to the third. The third root of 2 to the third. 3 goes into 3 one time. That's 2. Okay. So now I've got the third root of n to the 6th. 3 goes into 6 twice, so that's n squared. But now, don't forget about your exponent 2 that applies to everything. Okay? 2n squared, squared. 2n squared, squared. I would hope that you can do that in your head. 2 squared is 4, and n squared squared, n to the 4th. Okay? But if you don't know why, that is, that's because we've got 2n squared times itself. 2n squared times 2n squared. 2 times 2 is 4. N squared times n squared, that's n, that's n to the 4th.